Another abstract data type is queue. Let's take a look at how queues work. So this is an example of a queue. You insert something that is called enqueue, and when you take something out of the queue, that is called dequeue. So when we enqueue, we use the rear pointer, and when we dequeue, we use the front pointer. Let's Okay, now suppose it is an empty queue, so it means our rear pointer and our front pointer are at the same location. And when I enqueue something, for example, I have added 3 here, then my rear pointer will be along the next position because I have enqueued, so I will increment my rear pointer. And when and the DQ pointer is still there. Sorry, not the DQ pointer, the front pointer is still there. Let me change the color. So suppose it is my front pointer and I'm using purple for my rear pointer. Then I will add 4 here, so my rear pointer will be here. Q follows first in, first out approach instead of first in, last out approach like in stacks. Okay, so let's have a short dry run. For example, my rear pointer is 0 and my front pointer was also 0. I enqueued 3, so my rear pointer was 1. I enqueued 4, now my rear pointer is 2. I enqueued 5, now my rear pointer is 3. Now I want to dequeue something, so this 3 will be dequeued and my front pointer will be 1. And this is an empty space now. Let's raise it. So it is an empty space. Here are our indexes. Now my rear pointer is 3. I want to enqueue 7, so 7 is added here. Now my rear pointer is 4. You see there is no fourth place in this queue. So what should we do? We should, instead of 4, we should assign it this 0 because this place is still empty. So we will somehow do that, and if I want to insert something, I will say the rear pointer is at 0th location because that location is empty and my front pointer is still 1. Next, suppose I dequeue something, then my front pointer will be 2 and this 4 is dequeued. So you see it is a circular operation. This queue is circular and the pointers are working regardless of the length of my queue. So in our program we will keep track of the pointers, we will keep track of the two other variables. One is that is queue length. So queue length means how many items are here right now. The length should not be exceeded. So the queue length means how many items are present in the queue, while queue full actually means the total expected possible length of the queue. For example, here queue full is 4. So queue full variable is 4 here because at maximum we can keep only 4 items, and queue length variable is 2 right now. When the queue length variable is equal to the queue full variable, it means the pointers, the rear pointer will not be incremented. And when queue length is equal to 0, it means there is nothing to dequeue. So our stopping condition takes into consideration these two variables. Now, here are some use cases where the queues can be used. For example, print spooling. There are multiple printing jobs at a printer, and printer takes them in a queue and execute them one by one. CPU task scheduling, customer service systems uses queues. When you call to a health center, for example, you are calling in Jazz Health Center, they are always very busy, and they put you in waiting, and they follow a queued approach to answer your call. Network packet processing, job scheduling, messaging queues, elevator systems when there are multiple flow requests coming along. So in the all similar cases, we use queues. Ticket booking systems also uses queues in a sequence. Now let's take a look at the code for queue here. So first of all, we have some important variables. Queue length is initially 0 because the queue is empty. Queue full is the maximum capacity of your queue. I have my queue's maximum capacity is 5. Rear pointer is the location where we will enqueue something. Front pointer is the location where we will get something out of the queue. We will dequeue something. And then I have my queue initialized with nuns using this for loop. Now let's discuss the enqueue function. So here at line number 7, I have defined my function. Then from the above, I am updating these two variables in this function. So I want to make sure that the global variables are being used here to avoid any inconsistency in my program. Then I will check for the stopping condition. So my stopping condition is whenever the length is equal to the queue full variable, the queue is full and we can't enqueue anything. If that's not the case, it means queue has a place. That place is rear pointer. So we will add the item at the rear pointer, then we will increment the rear pointer. After increment, if we notice that the rear pointer is like out of bound, for example, my queue full is 5, it means my indexes for my list are 0, 1, 2, 3, 4. And if the rear pointer is 5, there is no place to access the fifth location of fifth index. So that means in case of a circular queue, it should be 0. So I will check if this condition is met. I will make my rear pointer to 0. I will add 1 in the queue length because one item has been added. Now in my dequeue function, again I am updating some variables, so I will use them as global variable, and then I will check if queue length is 0, it means there is nothing to dequeue, and if there are some things to dequeue, I will dequeue it from the front pointer, make it none, then I will increment my front pointer. And if again like the rear pointer, if my front pointer is out of the bound of my list, then I will make it 0 again because it is a circular queue. Now let's run the program. You see, I inserted 5, 6, 7, 8 and 10. Then I gave it 11. It says cannot enqueue, cannot enqueue 9. And if I'll dequeue something and then again enqueue, let's see if it does that. Okay, let's run it. Yes, it has dequeued 5. After dequeue, there was none at 5th place. And this 9 you see is not inserted at the end. It is inserted as this 9. Now my queue starts from this 6. So if I dequeue something, this 6 should be dequeued, not the 9. Because the oldest item is 6. Let's run it again. And you see it dequeued 6. So basically, it's a list, but you see it works as a circular queue.